In this section, we're going to be talking about solving systems of linear equations involving two variables and two equations. So, the best way to explain what these problems are asking is to go about graphing these problems. So, for example, in this problem, it says given y equals x plus 2 and y equals negative x, where do the lines intersect? Where do they intersect? So if we went about graphing these in the same coordinate plane, then to graph y equals x plus 2, if we remember from Algebra 1, whenever you have y equals mx plus b, meaning slope-intercept form, so something times x plus or minus some number, whatever number you have here represents your y-intercept. So that 2 says when y equals 2, we have a point right here. And then the number in front of the x tells us our rise over our run, how much we go up versus how much we go to the right. So because there's a 1 in front of this x, that means if we change that to a fraction, we get 1 over 1. So for every 1 we go up, we go 1 to the right. So from this point, if we go up 1 and right 1, we get a new point. If we go up 1 again and right 1 again, we get another new point. And we could also do the exact opposite. Down 1, left 1. Down 1 again, left 1 again. So that's just a quick reminder of how to graph using slope-intercept form, which gives us a first line that looks something like this. From here, we now have y equals negative x. So what number is being added to the x? 0. So we get a point right here. And now that negative x tells us we have a negative 1 in front of our x, which means we have a negative 1 over 1 if we want to change that to a fraction. So this says we go down 1 for every 1 we go to the right. So starting at this point, we'll go down 1, right 1, we get a new point. Down 1, right 1 again, we get another new point. And then the exact opposite, up 1, left 1, and then up 1, left 1 again. Which means our other line, y equals negative x, looks something like that. So where do these two lines intersect? At this point. Negative 1, comma 1, when x equals negative 1, when y equals positive 1. And this point is the solution to this system of linear equations. So whenever you're asked to solve a system of linear equations, it's really just saying what point or points do the two lines intersect one another. As you can probably guess, the graphing method is an extremely long and tedious process and extremely inaccurate. What would have happened if those two lines intersected at the point 1/79th, comma, negative 2 over 17? That's a very difficult point to just guess by looking at it. So we introduced the two most common ways to solve these problems. The first being the substitution method. The substitution method says the first thing that we want to do is isolate one of the variables. After we isolate it, meaning get it alone, we're going to plug its value into the other equation. Always remember, whatever value you find, you have to plug into the other equation. If you plug it into the equation you just isolated, you'll get something like 2 equals 2 or 0 equals 0, which typically means infinite solutions, but that's just because you did it wrong. Make sure you always plug it into the other equation. And from there, we're going to solve for the lone variable. So when we plug one variable into the other equation, we'll now be left with just one variable, meaning just x or just y, and we can solve for it. And once we solve for that value, we can use that value to find the other variable's value. So let's go ahead and give that a try in this problem. We have y minus x equals 3, and y plus x plus 6 equals 0. So looking at this, the easier of the two problems to get one variable alone hopefully should strike you as this y. All we have to do is add x to each side of the equation, and we immediately have y equals x plus 3. The y is alone. We now take y equals x plus 3 and plug x plus 3 into this y value, which gives us x plus 3 for y plus x plus 6 equals 0. If we combine our like terms, x plus x gives us 2x, 3 plus 6 gives us plus 9, and that's equal to 0. Solving for x, we'll subtract 9 from each side to get 2x equals 9, and dividing each side by 2, we have x equals 9 halves. Now we can use this value in the equation for y to get our y value. Since y equals x plus 3 and x equals 9 over 2, then that means y equals 9 over 2 plus 3. And to solve this, we just need a common denominator. We put 3 over 1. The common denominator between 2 and 1 is 2, so we'll multiply this 3 over 1 by 2 over 2, which gives us y equals 9 over 2 plus 6 over 2. And when we combine our numerators, we get y equals 15 over 2. So what point solves this system of linear equations? The point x equals 9 over 2 and y equals 15 over 2. Which would have been a decently difficult value to just guess had we used the graphing method. Okay, from here, go ahead and take a moment. Pause the video, see if you can't find the solution to 2y minus 2x equals 4 and x plus y equals 0. Alright, so going through this together, the first thing we should notice is that the easiest value to get alone is going to be either this x or this y. It doesn't matter which one you decide to solve for using the substitution method. So since we just did the previous problem solving for y, I'm going to do this one solving for x to show you that you can use either one. So we'll subtract y from each side to get x equals negative y. And now we'll take this negative y and plug it into the x value in our other equation, which gives us 2y minus 2 times x is negative y equals 4. So that gives us 2y, and then negative 2 times negative y gives us plus 2y equals 4. 2y plus 2y is 4y equals 4. And dividing each side by 4, we get y equals 1. And since y is equal to 1, we now go back to our equation where we solve for x alone. So x equals negative y, so negative times 1 means x equals negative 1. So our solution is x comma y, which means negative 1 comma 1. Unless it's a story problem, always remember to give your solution as a coordinate, because this is the point of intersection that solves the two lines. From here, also notice that this is exactly the answer we got in the first problem. These are two different equations than what we started with in the first problem when we graphed them, but they actually end up representing the same lines. We've just moved them around and multiplied by different numbers, so that's always something to be aware of. A lot of times it will look like you're dealing with a very complicated problem, but in reality it's just something is being multiplied to both sides. Like in this case, the only difference between this problem and the first is that we multiplied by a 2 and moved our x around. Okay, so from here, let's go ahead and move on to the addition method. The addition method is the most commonly used type of method because it's easier to use based on what you've learned in the past in mathematics, although it takes a bit more work. So the addition method says we are going to line up our variables and our equal signs. The two equations basically have to look like mirrors of one another. X on top of x, y on top of y, equal sign on top of equal sign, and constant on top of constant. And once we do this, we will multiply one or both of the equations by a certain number. We do this to get opposite coefficients, meaning the numbers in front of your variable, like this 4 in front of this y. We want them to have opposite values in the equations for one of the variables. So that means if, for instance, we had y in the first equation and 2y in the second equation, then we would multiply the first equation by negative 2. So that we would have negative 2y in the first and positive 2y in the second, opposite coefficients. From there, we will then add the two equations together because it's going to cancel out that variable that we just got the opposite coefficients for, leaving us with one lone variable that we can now solve for. And once we solve for that, just like with the substitution method, we will use its value to solve for the other variable. So let's go ahead and try this out. We have 3x minus 7y equals negative 3, and negative 5x equals negative 21y plus 5. So in this problem, to use the addition method, the equations have to match how they look, meaning we need to move this negative 21y to the other side of the equation, which will get the x and y together equals some constant in both equations. So I'm going to add 21y to each side of the equation, and now copy down the first equation, 3x minus 7y equals negative 3, and now copy down the new second equation, negative 5x plus 21y equals 5. And now from here, we need an opposite value for one of the variables. If we wanted to get opposite values for the x's, we'd have to multiply the first equation by 5 to get 15, and the second equation by 3 to get negative 15. But to get opposite y's, we would only need to multiply the first equation by 3 to get negative 21 and positive 21. So we'll just do that, as it'll be a lot faster. We're going to multiply the entire first equation, meaning the left and right sides of the equation, by positive 3. When we do that, we have to distribute the 3, which gives us 9x minus 21y equals negative 9. And then we copy the second equation back down, negative 5x plus 21y equals 5. And now we can use the addition method because negative 21y and positive 21y are opposites. So when we add the equations together, 9x plus negative 5x gives us 4x. Negative 21y plus 21y cancels off. And this is equal to negative 9 plus 5, which is negative 4. Dividing each side by 4 to get the x alone, we get x equals negative 1. Now we have to go back to one of our original equations to solve for y. It doesn't matter which one we pick. I'm just going to go ahead and pick the second one. We have negative 5x, and x is negative 1, so negative 5 times negative 1 equals negative 21y plus 5. Negative 5 times negative 1 gives us positive 5 equals negative 21y plus 5. We'll subtract 5 from each side of the equation, which gives us 0 equals negative 21y. And finally, dividing each side by negative 21 gives us y equals 0. So the solution to these two original systems of linear, original system of linear equations, that is x comma y, meaning negative 1 comma 0. Before you try the next ones, I want to make a quick note that if your answer, meaning if during your work you ever end up getting a equals a, meaning some number equals itself and all your variables are gone, then that means that there are infinite solutions. This means that both of the lines are equal to each other. They lie right on top of each other, so they intersect at every point. From there, a equals b. If you end up getting one number equals another number and your variables are gone, then there does not exist a solution. You cannot have 1 equals 2. It's impossible, which means the two lines will never intersect, meaning they're parallel. Just to be clear, a reminder, as we have only discussed this maybe a couple of times in these videos, this capital looking E that's backwards with a line through it means there exists, and then the same symbol but with a diagonal line crossing through it means there does not exist. It's a symbol that comes up quite often in math, so it's worth being familiar with it. Okay. So, with these in mind, go ahead and take a moment. See if you can't solve these two problems. Okay, so trying these together, you can use either method you prefer, the addition method or substitution method, and it's worth noting that sometimes you need to figure out which one will be the easier to use. For instance, in this first example, the addition method will be easier since it's all lined up, and we can quickly see that if we multiply the top equation by 2, we will get an opposite value for our y's, negative 4 and positive 4. So if we multiply this by 2, we'll get 10x minus 4y equals 2, and the bottom equation stays negative 10x plus 4y equals negative 2. If we add these equations together, 10x minus 10x gives us 0. Negative 4y plus 4y gives us 0. And 2 plus negative 2 gives us 0. So we have 0 equals 0. This will always be true, meaning this is our first case. There are infinite solutions because these two lines intersect completely. They don't intersect at one point, they literally lie on top of one another, so any point on the first line will be a point on the second line. From here, we'll quickly use the substitution method. We can take y equals x plus 3 and plug it in for this x. We have plug it in for this y. So we have x plus 3 for y minus x equals 6. Oh, I copied that down wrong. I apologize. Again, we're plugging this in for y. We plug in x plus 3 for y. We get x plus 3. I wrote x plus y before. I apologize. Minus x equals 6. That's better. Now we combine our like terms. X minus x cancels off, leaving us with 3 equals 6. This is impossible. 3 can never equal 6 no matter what x or y values we choose, which means we have the second case, a equals b, meaning there does not exist a solution.